one, merge four ordered arrays. All right? And what is the minimum number of comparisons to get the job done? Here, what's the meaning, get the job done? That means for the worst case. Because only you can handle the worst case, then you can get the job done, right? If it's not a worst case, best case, average case, you can only get partial job done, not a complete job done, right? Only the worst case you can get the job done. Although you cannot see the word worst case explicitly, but based on the simple analysis, you can see that. All right, so let's do the worst case. The reason we need to emphasize this worst case because we need to pick the right formula for the worst case. Merge operation, worst case, right? Still, we used that before, n plus n minus 1. Merge two ordered arrays with n size, total number of elements minus 1. All right. But here, the hard part is you have 4 ordered arrays. You have many different ways to do the merge, right? Can you exhaust all the possible ways? That's one way to find a solution, right? Exhaust all the possibilities. But that one may not be very good because you may miss some of the possibilities, right? You may miss some of the possibilities. Another thing is there is too much work. You want to do it in a relatively smart way, so you do not need to do all the cases. So here, I like to give you partial information in this way. 4. When we have 4 ordered arrays, you have too many, merge possibilities, right? Too many. All right, so based on some strategy we used again and again in this class, so we can take this strategy. Try simple cases, right? Simple cases. Can we make our case simpler? And then we work on it, then get some experience, then work on this case. All right. 4 ordered arrays. If we start from 2 ordered arrays, that's trivial, right? Yeah. If the number of ordered arrays, if that number is 2, then we apply this formula directly and it's solved. All right, so now the next case. We work on 3 ordered arrays. We change from 2 to 3 ordered arrays. Can we solve this problem? 3 ordered arrays, right? Right? So here, let me recommend one special way to solve it. 3, here I like to look at a general case. 3 ordered arrays with array sizes A1, A2, and A3. Okay? A1, A2, A3 for 3 positive integers. Not necessarily in order, could be in any order, arbitrary 3 positive integers. Now, let us do the same thing, merge these 3 ordered arrays. What is the minimum number of comparisons? If we can figure out this special case, then we go to 4 ordered arrays. You will see not too much harder. So, because you have some partial result you can use. Okay? All right, so let's work on this one. Let's just merge A1, A2. A1, A2 first. So you may ask why A1, A2? Yeah, because A1, A2 can be any two sizes, right? So when we work on A1, A2, that's pretty general, right? Yeah, all right. So A1, A2, then the number, the number of comparisons we need, number of comparisons we need, how many? Yeah. Worst case formula, right? Worst case formula. So it should be A1 plus A2 minus 1. But also, we need to write the number of elements after the merge. Right? A1 plus A2. Now, we need these two numbers. Okay? Excuse me. These two numbers, the number of comparisons and number of elements, size after the merge. All right? The first step. Second step, we merge this array with the third one. Right? The third one. Okay? Still, these two numbers, number of comparisons for the worst case, total elements. What are the total elements? Minus 1. A1 plus A2 plus A3 minus 1, right? Then the total elements, A1 plus A2 plus A3, right? All right. Now let's look at the total number of comparisons. These two numbers adding together, right? These two numbers adding together. So you can see 2 A1 plus A2 plus 1 A3 minus 2. Okay? How to make this number smallest, minimum. This number can vary, right? Based on different A1, A2, A3. This number can vary, right? All right? So can I rewrite this number as 2 times A1 plus A2 plus A3 minus 2 minus A3, right? Can I write this way? Why I write this way? Because if we write this way, this is the total elements, right? Total number of elements in these 3 arrays. Okay? Total number of elements in these 3 arrays, no matter what combination, what way you merge 3 arrays, arbitrary way you merge, this number always the same, right? Total number of elements never change. Never change. Yeah, but when you choose this A3, you can change the total number of comparisons, right? Yep. You have freedom to change A3. Yep. You have freedom to change A3. Now, how to make this expression minimum? You pick A3 largest. You choose largest A3. Then you can get a minimum number of comparisons for 3 ordered arrays. So that means the largest array you should leave to the last, right? Merge 2 smaller array sizes, smaller arrays, sizes smaller, leave the largest array the last. Okay? Okay? So then you can get the best solution. Okay? With this experience, that's for the 3 array case. Can you work on the 4 order case using a similar idea? You're pretty close to that, right? Pretty close to the solution. Here I introduce the way you should use later on when you try to solve some new problems yourselves. Okay? Yeah. Strategy. All right, next question, number 4. Give a 5-element array, say x1, 2, 3, 4, 5. It is known x1. Yeah. So when we compare, so here you can see when we compare x1 and x2, x1 is smaller. When we compare x3 and x4, x3 is smaller. When we compare x1 and x3, x1 is smaller. So you typically get the relationship among these elements in this way, in this diagram. But x5, you don't have any information. Okay? Larger, smaller, you don't have any information. All right, so now, here the question. The first question I want to ask you, question 1, which element can be eliminated from the consideration for the median? Right? Remember, I gave you this question before. Okay? So I don't remember in homework 1 or midterm test. You can find it, right? Probably both, right? I remember. So I give similar question twice. The second time I change a little bit. Okay? So which element can be eliminated from the consideration of median? So it can never be the median. There is no chance that element could be the median. Here I cannot tell you, so you need to find it out. So we can take it away from consideration of the median. Okay? Right. So after we take it away, second question. So in the remaining 4 elements, what is the role of the original median? Can you look at this question? What is the role of the original median? Because original median, the third smallest, right? Third smallest. That's the original median. 5 element array. But after you remove that one element, one special element that cannot be the median, after you remove it, you only have 4 elements left. In those 4 elements, the original median won't be third smallest anymore, right? You need to update that rank. So we call that rank. So third smallest, the rank is 3. There is a special terminology, rank equals 3, third smallest. Then this row, I should change the rank, okay? What is the rank of the original median? In the remaining elements, then the median, its rank should be changed, should be updated. After you update that rank number, then you can use your experience to solve it. Your experience means we did that problem before. It's not a new problem. We did that problem before. I hope you can connect to the right questions. We did that before. Not once, multiple times actually. Multiple times. Then you can solve this problem. I cannot give you too much information already the critical information No more. That's all I can give you. Hope you can figure out. Okay, try your best. Figure out. All right. The last question, question number 5. This one. This one, I want to give you comments in this one. 5-element array. And we know X3 is the median. That information is given. Median. Right? Now we want to sort this array, but we want to use the minimum number of comparisons. Okay? Here we can connect this question to 2 previous old questions. We can connect to 2 previous old questions. The first one, in the notes, we did this question. You can look at the notes, sorting 5-element array, right? We did that. But when we do that, we didn't have this information. X3 is the median. We didn't have that. And our solution, our solution, 7 comparisons, right? Our solution, 7 comparisons. Okay? That means with this extra information, median information, we should do better than 7. Smaller number of comparisons than 7. Okay? 7, we don't have that information. We can already do in 7 comparisons. With this median information, we can only do better. We can only do better than that. Here, so let me give you my grading criteria. What's that? If you can solve it in 6 comparisons, so I do not write all the words. If you can solve it in 6 comparisons, you'll get 2 points. Okay? Because that's not the best solution. If you can solve it in 5 comparisons, then you can get 4 credit, 4 points. Each one worth 4 points. Yeah. 6 comparisons, not the best solution. But 5 comparisons, that's the best solution. You can earn 4 credit, otherwise half credit. But this one is a solution question. That means you need to give me the solution details, not just the number. Put 6, put 5. No, you cannot just give me that. You need to show you, or you need to tell me the main idea. Or, so you at least let me know how do you solve it, right? At least you need to tell me you can solve it, not just by guess or number, right? You need to tell me how can you solve it. That's the bottom line. All right. So that's the first question we can connect. Second, we have a similar question we can connect. That is, remember, that is the homework 2, question number 25, the last question. Last question of homework assignment number 2. Remember that? We have 4 elements, right? In that one, we have 4 elements, x1, x2, x3, x4. And we know x2 is the second smallest. These 2 questions, similar structure, only difference is the element number is different. 4 elements in this question and 5 elements in our current question. That's the only difference. So the solution idea could be the same solution idea. In that one, I give you some hint. In that one, but here, let me just continue that hint a little more. Right? To solve this problem, there are 2 different ways. 2 different ways. The first way, brute force method. Brute second method, remember I used that word, aha method. Aha method. Okay? Yeah. In the hint for the homework sum number 2 question, I mentioned that aha method. Here, the same thing. Yeah. But the brute force method for this one, if you want to solve the brute force method, could be very hard. For this question, not very hard. The brute force method, I think you can figure out. You just try a few times, you can figure out. But this one, the brute force method, is very hard. Okay? Very hard. If you try, very hard. So, it's hard for me. So when I try, I failed many times. I couldn't get it. I spent a lot of time, but I couldn't get it. But I have the aha method. Very simple. If you just get the insight, this one you rely on insight. If you get the insight, aha, click, solution, you only need one sentence. One sentence, you get a solution. That magic. I like you find it by yourself, so then you can enjoy it. You really enjoy it. You will enjoy that experience. I don't want to grab that experience away from you. So much pleasure, so I like you have it. Okay? The aha way. Okay? One sentence. When you get insight, just one sentence. A difficult question, but piece of cake. You solve it. But you need to take the right view. Aha means you have to take the right view. Okay? Right view. We can describe it in one sentence. That's it. Okay? All right, so that's all the information I can give you here at this point. So you have Monday, the whole day. If you want to get more points, you have one full day on Monday. All right. Yeah. So then.